Greetings, viewers. Welcome back to my channel. I am your tutor, Mr. Kyra, and in this video, I'll be doing the science paper one in internal. And the questions that I'll be doing are questions on waves and light, as one of my students requested for. Tune in until the end, and I hope this video benefits you. Okay, so uh, the first question was in section B, the question on waves. Okay, so the question reads, um, figure B 5.1 below is a diagram showing a wave traveling along a spring in the direction shown. Okay, below is a diagram showing a wave traveling along a spring in the direction of the wave. So this is the wave. Okay, we can see this wave they've given us in the diagram, that spring. Okay, and we can also see the arrow they are using to represent the direction of the wave. So um question A says, in what way is this wave the same as a sound wave? In what way is this wave the same as a sound wave? So, in order to be able to answer this question, you need to have knowledge about the two types of waves. Okay, knowledge about the two types of waves. So, there's there are two types of waves, of which, since we are revising, I will I'll let you know. So there's the longitudinal waves. Okay, there's the longitudinal, and also there's transverse. Okay, there's transverse waves. Okay, so um what you have to know about longitudinal waves, when it comes to longitudinal waves, is one in which the particle, okay, the particle vibrates parallel to the direction of the wave. Okay, let me give you a picture. So this is a particle. So when it develops a wave, okay, remember a wave is defined as the disturbance traveling along a medium. A medium is any object carrying the wave. Okay, and that medium should have particles. So this is how it will happen. So if the wave inserted in this particle is maybe traveling in the right direction, okay, in the right direction. So how I will use yellow color for the direction in which the particle is vibrating. So the particle will also vibrate in the same direction as the wave. Okay, that's the picture here. That's what happens in a longitudinal wave. Okay, the particle is vibrating parallel to the direction of the wave. Okay, and it's important that you know some of the examples. Okay, and the examples of a longitudinal wave is the wave itself, which we are able to see in the spring. Okay, in this spring. Okay, the waves in a spring, they are longitudinal waves, because the parts of the spring, as you are able to see, the parts of the spring, they are vibrating parallel to the direction of the wave. Another example is a sound wave. Okay, a sound wave is an example of a longitudinal wave. Okay, there are many more examples which I believe you will read through in your free time. Then for a longitudinal wave, okay, for a longitudinal wave, I mean, sorry, a transverse wave. Okay, for a transverse wave is defined as a wave in which a particle vibrates um perpendicular, okay, perpendicular to the direction of the wave. It vibrates 90 degrees, at an angle of 90 degrees, to the direction of the wave. Let me give you a picture as well. this is the particle, okay, and the wave is inserted in this particle. So this particle will vibrate. Let's say, for example, it vibrates in the right direction. I mean the wave is moving in the right direction. So this is how the particle will vibrate. The particle will vibrate either upwards. Sorry, that line is bent. It will vibrate either upwards, okay, or downwards. As you can see, the vibration is perpendicular. It's forming in 90 degrees, okay, 90 degrees to the direction of an angle, to the direction of the wave. Sorry, okay. Yes, and the most common example of a transverse wave is water waves, okay. Water waves, light waves, electromagnetic waves, etc, etc. Okay. Okay, so now to answer the questions. So um having explained about a longitudinal wave and the relationship between the waves in the spring and the sound waves. So this is the answer that I gave. So the wave in the spring is similar to a sound wave in the sense that the parts of the spring are vibrating parallel to the direction of the wave, which is similar to the vibration of particles in a sound wave. Okay, that's that. So then question B says, what are regions U and W? What are regions U and W? Okay, so uh, when we zoom in, so part U. Part U there is, we can say where part U is, right? This region, this part. Okay, so have you seen how the spring is, how the parts of the spring are being compressed? Okay, how they are moving closer to one another. Okay, so those are part, that's part U, and then there is part W. Part W, that's where the parts of the spring are stretching, okay, the stretches there. Okay, so you will notice this in a spring, okay. There are parts which are being compressed and parts which are being stretched. The parts which are stretched, which are being compressed, which is part U. So part U, we call it, we call them the compressions, okay. So part two is the compressions, okay. And then W, these parts where the spring is stretching, we call them rarefactions, okay. Rarefactions. Okay, so I guess I indicated the answers as well over here. Yeah, so those are the answers: compression and rarefactions. Okay, uh, we can proceed to the next question. So a ray of light, that's question B6. A ray of light travels from air into water at an angle of 40 degrees between the normal and the incident ray. If this produces an angle of refraction of 29 degrees, calculate one, the refractive index of water, then two, the critical angle of water. Okay, so before we answer that question, okay, I want us to look at first the ways in which light changes direction. Okay, light changes its direction. So let's say this is a ray of light. Okay, so you will notice that when a ray of light hits a surface, you'll notice that on some surfaces this light will be it will be reflected backwards, okay, depending at an angle. So the light will bounce. Okay, if at all the light was traveling at this angle, okay, then it bounces away from that surface. So we call this bouncing of light as a reflection. Okay, reflection. This is reflection of light. It's basically the bouncing back of light when it hits a shiny surface. Okay, a shiny surface or a mirror surface. Okay, and then let's say we have light traveling through different mediums. Okay, different mediums. Okay, and this line here, it is the line which is dividing those mediums. Let's say this is the medium of air, and this is the medium of water. Or maybe let's just say that when light is traveling into two different mediums of different densities. Let's say this medium here is more denser. So I'll be using arrows to indicate the one which is more, and the arrow pointing downwards to say this one which is less. Um, so this one which is less denser. Okay, this one which is less denser. So when light travels through these mediums, okay, through these mediums. So let's say the light. Let's say this is the ray of light. Okay, so it is traveling now from a region where it's more denser to the to the region where it is less denser. So what we will happen is that the direction of this light will bend. Okay, the direction of this light will bend. So since it's traveling to a medium which is more denser into a medium which is less. So this light will bend. Okay, it will probably bend in that direction. Okay, or maybe if it was moving like that, you notice that it bends like that. Okay, so the basic point here is that so this is what we call refraction. Okay, refraction is the bending of light. Okay, refraction is the bending of the direction of light. Okay, so now this is what you have to know. These are the rules when it comes to refraction. Since the question we've been given, it's talking about refraction. So suppose that okay, this black line, let's say this black line is the barrier. Okay, so this is the the barrier. Okay, the barrier which is dividing the mediums. Okay, the side which is more denser, and the part which is less denser. Okay, so and then the arrow in blue, is the ray of light. Okay, that's light. So let's say that the this media where the light is coming from, this medium is more denser. Okay, remember I'm using the arrows for more. Okay, so this region is more denser, uh, is more denser. Okay, and then this region is less denser. Okay, less denser. Okay, so the this is what we do. Whenever whenever a ray of light meets the barrier, okay, there where it contacts the barrier, okay, the barrier which is dividing the two mediums, we have to draw a straight line there. So we assume a straight line there, which this line, we call it, we are calling it what? The line of normal. Okay, the line of normal. Yeah. Okay, and follow me clearly. I want you to follow me, to follow me closely here. Um, so this is the rule. This is how it works. So when light is traveling to a region which is more denser, okay, to a region which is more denser, and then it is going, okay, it is going into a region, okay, this region which is less denser, okay, which is less denser. This ray of light, it bends, the way it bends, it will bend far away, okay, far away from from the line of norm. Okay, have you seen ka? Far away from the line of norm. Remember, remember to say that this line here, this line here is the line of norm. Okay, so this ray of light, which was let me use this the same blue marker. So this is how it will bend. It will bend far away, okay, far away from the line of norm. Okay, yeah, and if it were to be the opposite, okay, if this was the opposite, let's say that this time the upper part which was more denser, it becomes less denser, okay, and then the lower part is the one which is more denser. Okay, so this is how a light a ray of light will move. Okay, so um suppose that the ray of light is traveling, okay, so it is traveling like that. Okay, so remember that the line of norm should be the point at which the ray of light contacts the barrier, the area with the part which is dividing the mediums. So this light is traveling from a region which is less denser, this region, to a region which is more denser. So the opposite will happen. Remember, when it was traveling from a region which was which was more denser into a region which was less denser, the ray of light bend away from the line of norm. But this time, when the ray of light is traveling from a less dense medium to a more denser medium, the ray of light will bend towards, okay, towards this line of norm. Okay, hope you are able to see. Okay, so those are the rules you are supposed to consider. Those are the things you are supposed to know. Okay, so another thing you are supposed to know is that there is what we call the incident ray. Okay, so the incident ray is basically the light, the ray of light which is traveling towards the barrier. Okay, towards the barrier, which in this case this this line, okay, this line is the one which will be the incident ray. Okay, the incident ray. Okay, and then there is what we call the angle. Okay, the angle between the incident ray and the line of normal. This one we call the 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 angle of incident. Okay, so the angle of incident. Okay, yeah, and then uh, this 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 ray of light which has been refracted, the one which has bent, okay, the one which has bent, this one we call it the refracted ray. Okay, the refracted ray. Okay, and then also it also forms an angle between the line of normal and the refracted ray. So this one we call it the angle of refraction. Okay, those are the those are some of the terminologies which are there. Okay, so to go back to answering the question, our question was saying a ray of light travels from air into water at an angle of 45 degrees between the normal and the incident ray. Okay, so the diagram is already here. So this is the these are the two mediums, the medium of air and the medium of water. So what you know is that what you have to know is that the medium of air is what is more. I mean, it's less, it's less denser, okay, that as compared to the medium of water, which is more denser. Okay, so let's say a ray of light is is approaching. Okay, so it is approaching from the medium of from the medium of air. It's heading towards the medium of water. uh, so like that, towards the medium of water. So remember I told you that I told you that the point of contact between the barrier between the barrier and the ray of light there, that's where we draw the line of normal. Okay, that's where we draw the line of normal. So the line I'll draw it like that. Okay, so this light, okay, this light is traveling at an angle of what, at an angle to between the line of normal and the incident ray at 40 degrees. So looking at where it's coming from, where it's coming from is less denser. So where it's going, where it's heading to is more denser. So the light is supposed to bend towards what, I'm pretty sure you have already figured it out. So the ray will bend towards the line of normal. Okay, where the angle of refraction will be what, will be 29 degrees. This is the angle of incidence. Okay, so that's the basic picture there. So now the question says the calculate the refractive index. So this is how we will calculate the refractive index. So we will write the formula. Mm, so the formula will be, so the refractive index is denoted by the letter n. Okay, so we say n equal to sine incidence over sine refracted angle. So the r, this r here is for the refracted angle. Then sine incidence, this is the angle of the incidence. Okay, so of which the angle of incidence we said, so that was sine 40 degrees, okay, over sine sine refracted angle of refraction, which is 29. So when we punch this on our calculator, we'll find that the answer will be 1.3 degrees, okay. That is the refractive index. Actually, it's not supposed to be a degree here. Yeah, so of which we can now write our final answer in the answer space, where we say 1.3. Okay, then to move on to the next question. So question 2, question Roman numeral 2 says, find the critical angle of water. The critical angle of water. So this is the formula we use when calculating the critical angle of water. So we will say the critical angle denoted by C will say equal to sine, okay, sine inverse equal to, so we say 1 over the refractive index, okay, 1 over the refractive. So we'll say sine inverse, then we say 1 over the refractive index, which we answered was 1.3, okay, of which if we when we punch this on our calculator, we say shift then press sine, so it will bring you sine inverse, then say 1 over, as you say, open bracket, 1 divided by 1.3, then close bracket, then press equals, you will get 50 degrees. So which the final answer that you get, you can write it now on your spacing as 50 degrees, like that. Then you are done with this question. So thank you.